we're going to go ahead and get started. Again, thank you so much for being with us today. Your time is very valuable as an educator, especially this school year. So we are excited to spend some time with you. So if you're still introducing yourself, keep on doing so, but we would love to introduce who we are on the other side of the camera. So hi everybody, if we have not met before, my name is Erin. If you want to tweet with me, at me, to me, you can do that at Erin K. Cook. That's my handle. My background is in upper elementary education, coaching, and special ed. I did that for a nice long time, and now I'm partnering with InterOrbit, and I lead our professional learning. And the crazy NGSS three-dimensional science learning is my passion. And the first word that I think of when I think of data is empowered. Sometimes I feel like I can get in an analysis paralysis making decisions in my life or anything like that. So using data to inform decision-making makes me feel empowered. And this is my colleague, Brendan.
Howdy, howdy, everyone. My name is Brendan Finch. I taught middle and high school science for 7 years, and I've written a lot of the content on Rocket Lit and on InterOrbit, and today's conversation is sort of a crystallization of a lot of the things that we've learned, either writing content or working with schools and districts. And to me, data means science. So everything that we're talking about today, not just instructionally, but on a more actually scientific scale, that's what data is. It's all about, that's what science is. It's all about data and not just saying things, but making claims based on evidence. And that's what we're all about. Okay, so we're here today to talk about data and analyzing it and interpreting it because we've written thousands of these assessment items now through InterOrbit. If you have not checked out InterOrbit yet, you should probably go do that. And we'll drop a link to our calendar in the chat so you can go ahead and schedule a time to chat with us. We are offering free pilots, and we're happy to have you and a few of your teachers, or if you're a teacher and a few of your colleagues, join us and check out the platform. We have all these phenomena and all these assessment items that we write specifically around the NGSS to scaffold up from knowledge to a little bit of representation to actual sense making. And to support all of this and to talk more about data, so we track data at a very granular level, looking at what students are doing with an SEP, what elements in 3.5 have been assessed and what have not been assessed, and really allow you to dig down so that as a district coordinator or as a classroom teacher, you can go in and say, all right, in this unit, my students did well. In that unit, your students didn't do as well. Like, let's compare our lessons and talk about that. At a broader district level, we can say, all right, we need to make adjustments to this unit in this particular standard to make sure that we can see the change over time we're looking to see. So we track all this data, and we're really excited to chat with you about analyzing and interpreting data for the NGSS. And then we can talk later about analyzing, interpreting your students and teachers' data with InterOrbit.
See what you did there. That was very nice, Brendan. Well, great. So now that you know us a little bit more, we'd love to continue to get to know you. So we are going to ask this question of you, and we're going to build a word cloud together across all of our responses from our attendees today, just to see where we kind of are with this get to know you question. So I first want you to think about this question. What do you find most difficult about teaching and assessing this SEP, the science and engineering practice, analyzing and interpreting data? What's really cool about this word cloud is going to kind of change as people respond, which is really neat. And then the larger words will be more thematic elements. So once more people respond and have like similar ideas, those words will kind of like merge together and become larger. So we see time, reliable items. Yep. Scaffolding. We're going to talk about scaffolding today. It's like they read our minds, Brendan. That's great. Engagement. Yeah, the active interpreting, because that does seem kind of vague. Background knowledge, literacy, messy data. Yes, I totally understand that as well. Binding valid data. Yep, having those really strong phenomenon for students to analyze. That's great. This is helpful not only for us in our presentation today, so we can make sure to address these major thematic elements, but you kind of know too, just kind of a pulse across the country and even across the world. Like, where are people with this idea of assessing and teaching this science and engineering practice? Beautiful. Well done, everybody. Thank you so much for sharing that with us. So now that we know a little bit more about you, let's go ahead and lay the foundation of what we're doing in the 60 minutes together. By the end of our time, we're going to have experience analyzing assessment items that cover this science and engineering practice analyzing, interpreting data for two things: complexity and detail. And these are going to be two strategies that you guys can kind of use as handles when you're examining your own assessment items as well. And it's things that we really think about crafting with our assessment items in orbit. We're going to be very active in our learning together today. It's still kind of a webinar format, but we're going to have activities for you to engage with us. So we really encourage you to lean in. We're going to first start with some background knowledge building ideas, just make sure we're all on the same page about what are three-dimensional standards. Then we're going to really dive into this practice of analyzing, interpreting data to make sure we really know how it progresses from K2 all the way to 912. Then we're going to hear from Brendan in a mini presentation about some just general SEP assessment ideas and things to consider. And then we're going to really dive into a lot of different examples of this one SEP and how to assess it. And then we'll end our session today applying all of our new learnings to some even more new phenomena and question items, because we can't get enough of them, for you guys to practice the skills and strategies we're talking about today. And we are going to be recording our session today, so we can send it out to folks who weren't able to make it. So without further ado, let's go ahead and kick it to Brendan just to help us lay some foundational ideas and terms that we're going to be using a lot today, just so we're all on the same page.
Before we start talking about sense making and we start talking like analyzing and interpreting data, we want to make sure that we are on the same page with these basic elements of the NGSS. Many of you have been to these sessions before, you know these things, but we want to make sure for anyone who's not on that level that we have those defined. So the NGSS will commonly be referred to as having three dimensions. So these three dimensions are the SEPs, and these are these sometimes called the practices or the science and engineering practices. And this is what students do. Commonly, we'll refer to these as the skills that students need. So scientists and engineers will have these skills and they'll apply these skills to novel phenomena and situations. The second dimension of the NGSS are the DCIs. These are the disciplinary core ideas. This is what students know, or the content. We've been assessing this and teaching this for a long, long time. Standards that say things like students know, blah, blah, blah. The mitochondria is the blank of the cell. These are the DCIs. They are very, very important as a basis for what students understand about the world, and then they can use the cross-cutting concepts of the SCPs to apply those ideas. The cross-cutting concepts are how students think. I like to think of these as thematic elements. So in literature, there are certain themes that we see consistently throughout all types of books and all types of stories. These are the sort of structural elements of science. So the thematic elements are the cross-cutting concepts, things like patterns, structure, and function. They transcend all subject areas within science, and they're just really interesting structures that we can use to organize the world. All of this comes together. So we have our practices and our cross-cutting concepts and our DCIs, and we use these things to look at a phenomena or a problem to engage in sense making. And that is a really, really important thing. And this is what truly differentiates the NGSS from other standards, or any three-dimensional standards, frankly, from other standards where students are just regurgitating knowledge. So we want them to apply what they've learned to something they've never seen before in service of sense making. So they are making sense of, explaining why or how. Let's take a look at analyzing and interpreting data itself to talk about what that is and be really, really clear about that. So typically we're looking at data presented in a form to reveal patterns and relationships. Our global sea level fluctuations here are doing all kinds of crazy things over the last 550 million years. And you can, because it's organized this way, we can identify significant features and patterns. We're also able to use this data as evidence to support conclusions. So if we're trying to make a statement about what's happening with the oceans or with the sea level, we can use a graph like this presented in this way to present that as evidence to support our conclusions. Commonly, at least in the higher levels, we're going to use mathematics to represent relationships. So students will talk about slope or fit to slope, and they'll use all kinds of really, really awesome math at the high school level to look at that. And at lower levels, we'll just take into account sources of error. So what is wrong with this data? Most data, or most of the things that we're looking at only represent a limited scope of what is actually happening. So there are sources of error in how it's presented or in how it was collected. And then we also want students to engage in using digital tools to analyze and interpret that data as well. There are two main parts of the standards and of the K-12 progressions that we'll be talking about today. And those are SEP grade bands and elements. Grade bands are these large blocks of elements. So at K2 and 3.5 and 6.8 and 9.12, there are different levels of complexity, and all of these little bullet points below are called the elements. So elements are specific details that we're looking for students to engage in. So use and share pictures, drawings, and or writings of observations. A very explicitly defined element falls within a grade band. As we're going to see in the next activity, these climb up. This is in reference to what we're about to do in rigor from grades K2 to 3.5 to 6.8 to 9.12. And the next thing that we're going to do is we're going to look at the standards to really analyze how specific ideas in the grade level band that y'all work with either develop over time or what led up to that element within your grade level band.
So as Brendan was miming, we're going to do a quick activity for us to really dive into this science and engineering practice. So for us to really write curricula and assessments that are focused on the standards and what they're trying to do, we need to deeply know them. So this activity is going to be kind of a stab at that. And we're going to throw it back to the childhood classic Chutes and Ladders to do this activity. So what's going to happen in just a moment is I'm going to send you your own game board, pretty much just like Chutes and Ladders, but it's going to be the matrix of this science and engineering practice. How fun. Which all Chutes and Ladders games are about science standards. I'm just kidding. And what you're going to do is you're going to look at your grade band, or just pick one grade band that you really want to focus on. And then you're going to pick one element underneath your selected grade band. That's going to be kind of like your starting place, and you can go ahead and circle it, and I'll show you how to do that in our Jamboard in just a second. But then you're going to apply this idea of Chutes and Ladders. You're going to look down a chute, or you're going to look down the grade band just to the left, or the grade band prior, and think which element or which elements kind of spiral up to my current grade band element. And if you're K2, don't worry, you don't have to do a chute. But you'll kind of do that for your chutes, and then the opposite idea will be the same for your ladder. So I want you to look up a grade band prior and draw an arrow maybe to represent a ladder of where does that element that you're currently focused on in your current grade band, how does it progress in the next grade band up? So by the end, you'll have kind of your focus element, and you'll have your chutes and your ladders as well. All right, I know 3 minutes goes by really quickly, and no worries if you haven't finished your Chutes and Ladders yet. That's totally fine. The whole purpose is really just to deeply read these standards. So what I'd love for us to do, since we all kind of did that activity independently, I would love for us just to kind of summarize what we kind of saw or noticed in the Zoom chat together. So I'd love for you to think about this question, and then feel free to respond in the chat. In one sentence, describe how your SEP element that you chose, your targeted one, connected to the prior grade band, so your chute, and then how did it connect to your upcoming SEP element in the upcoming grade bands? How do you see those elements connecting to each other? So take a moment to think about that, and we'd love to hear your thoughts and synthesis in the chat. I already see one of our key words that we're going to talk about next, with complexity increasing over time, adding more detail as well as students increase the grade bands, the difference between qualitative and quantitative, and that kind of growing over time as well, ending in quantitative in high school. Making sense kind of first, then supporting analysis, and then verifying it with mathematics, like that too. Yes, that complexity and depth increases. Yeah, and so some of the elements will even kind of go together, or they're kind of like a related skill, which we'll kind of talk about in just a moment too. And we're going to talk about this today. Like you just said, is like our strategies for how you can not only scaffold students up to a higher grade band understanding, but how you can mix and match with different grade bands and elements to inform your assessment. So nail on the head right there. Beautiful. What I do want to share with you is how NSTA actually groups together and threads some of these elements across the grade bands. So you guys probably noticed this too while you were playing around on your own board. But what you'll notice is that some of these skills within this larger practice do have roots all the way in K2 progressing up to 912. But then some don't. Say, for example, I'm a 912 teacher, and I'm very concerned, or like, why don't my students, know this one element right here about limitation of data analysis? That's really because thematically with that skill, it was kind of newer introduced. It was only really introduced in 6.8. So obviously all of these skills will lead into this one, but thematically that skill is kind of a newer skill that was introduced later on. So it's interesting to see which skills, one, that are grouped together kind of thematically, how NSTA groups them, but then also to see which ones have roots in K2 all the way up through 912, and which are, a little bit newer depending on your grade band. So all of this really just to say, knowing how these progress and what the elements are really key to making intentional curricula and then intentional assessments, which is what we're going to talk about next with Brendan. So we're moving into our activity 2 of our time today, which is a mini presentation. And Brendan's first going to unpack just some general SEP assessment ideas and things to keep in mind. And then we're going to deeply dive into a lot of assessment items that are samples for this analyzing, interpreting data to give some teeth to this idea. So take it away, Brendan.
Here we go. All right. So let's first talk about representation versus sense making. In all of the assessments that we see teachers or districts upload or send us, this is the one element that seems to be a confounding factor. And we want to clarify the difference between these two things. So representation is communicating ideas that students have previously learned. And typically this can look a lot like sense making. So an example is explain how the bell curve in this graph shows that there's variation in traits among, like roly-polies or something like that. So in this case, if we've shown students a bell curve showing variation in traits of, plant height over time, and then we show them another bell curve, which is roly-poly, antenna length or something like that. Really what students are going to do is they're going to say, there is a distribution of traits and the average trait is this, and there are some that are bigger and some that are smaller, some greater, some less. And it's actually just regurgitating the exact same idea. We saw this in modeling where students would actually just redraw a model of molecules with longer arrows behind them. And they're not making sense of something novel. They're just showing you or giving the explanation that they had been given prior, and then they don't have to apply what they've learned. They just give you the other explanation that fit with this graph or this image. That's not to say that these don't have a place, so they're perfect for the beginning of a unit or a topic. We strongly recommend that you have representation questions in the beginning of your units, in the beginning of, addressing a new topic, scaffold up with this, but what's important here is that it's not sufficient evidence of an SEP proficiency. So if you have students look at a bell, curve in a graph to look at the variation of traits, and they just say the traits are varied and that there are, many traits that are this and then some that are that and some that are that they're not making sense of anything. They're representing knowledge. So sense making is a little bit different. And we want to make sure that that's clearly defined too. Typically it's explaining why or how to make sense of a novel phenomena. So not showing or not explaining that there are variation in traits, but why or how are those traits varied, and how does heredity or adaptation play into that? We strongly recommend that at first you give students lower grade level bands. The activity we just did with the chutes and the ladders is meant to get you to grapple with where students should have been right before they entered your grade level, and then where they need to go right after that. And once they're there and they're able to do that, then you can scaffold up to what they should be doing at the middle school or high school or 3-5 level, wherever y'all are at. At the beginning of the unit, we strongly recommend that the teacher models this through think alouds. If you give students a phenomena, and I think this was kind of communicated at the beginning of the NGSS, like at the inception, that we would just show them phenomena and the kids would like figure it out on their own, which is total insanity if you've tried this in your classroom. Instead, I would say show them phenomena, and as a teacher, go through and say, okay, well, we learned this about plate tectonics, and I understand this about density and pressure, and the thing that I'm seeing here, there's rocks and they're doing the rocky thing, and I guess if I take those ideas and I put them together, I can develop a model that shows why this would occur in this spot based on all the knowledge I have prior. So those think alouds are really, really important at the beginning of the unit. And speaking of what should happen at the beginning and of a unit, we have this really, really pretty graphic here that I want to show you. And there are 2 zones within your units where you can scaffold assessments. The first is the representation zone. So when you introduce a new topic to students, the DCI is the orange element of this mixed area graph. So you're mostly going to have students representing knowledge. The first few questions in all of our assessments are representation questions. Really, it's just regurgitation, they're knowledge questions. Maybe we'll sprinkle a little cross-cutting concept in there. So with something like variation of traits or adaptation, it's difficult to not talk about patterns when you're talking about these ideas. So the cross-cutting concept is like just a solid thing to put in there at any point in time. Later on in the unit, at the middle of the unit, we reach this little dotted line here, which I'll call the formative assessment area or line. And this is not, these aren't like hard and fast rules here. We're just showing the progression. So the SEP has almost no place in our mind at the very beginning of a unit, but at formative assessments, now you can have students look at flawed sense making. You could have them look at images of graphs or charts or analyses that other students, like some mock student has made. And now students can try to, describe why that is true, why it's not true, why that's a good analysis or interpretation, why the data does support that, or why it doesn't. And then later on at the end, you can have students generating their own data. You can have students creating their own graphs and interpreting the data that they create. That's where the SEP plays an equal share with the cross-cutting concept and the DCI. So at the very, very end, in the sense-making zone where we make some sense of this science, students are going to equally be representing things with knowledge and blending that with the cross-cutting concept, and then engaging in, actually developing those models. They're going to be planning those investigations or analyzing an investigative plan, or in this case, they're going to be, generating data or analyzing data and maybe constructing graphs and, organizing data for communication. So two things we're going to talk about in these in the next few slides, and this is really important because you are going to have to do this after I go through a couple examples. So we're going to kind of model pedagogy here. I am going to give you, my analysis of these questions and where they fall. And then you are going to have to go and do it on your own. I mean, I'm going to help you and give some explanation afterwards, but I just mean, pay attention to this, kids. So the grade level band is the first thing we're going to look at. And that's really just a test of complexity. So we're going to look at a couple question samples, and you're going to decide whether you think that this falls under the K2 grade level band, the 3.5, the 6.8, or the 9.12. And there is some room here. These are just our interpretations of this, but we just want you to be thinking about these questions. We find high school teachers often ask questions at the 3.5 or 6.8 grade level band with an SEP. And sometimes we find elementary school teachers are asking things that are way too advanced for what their students should be doing. So we want to make sure that we define, the level of complexity of these questions and that we start to think critically about these. The second thing that we're going to look at are the elements. And these are details. So at a certain level of complexity, at the 6.8 level, there are several different details in the student performance that we're looking for. And these are things, sometimes you can have a question that hits many details. Sometimes you'll have questions, especially at the 9.12 level, that really just hit one detail, because in 9.12 it gets really, really, really specific. And even new elements are introduced that weren't in previous grade bands. Okay, cool. So let's look at some examples here first. And I do want to just say that for Inner Orbit, we break all of this down for you. So as students take assessments, we'll show you what standards are good to go, where students have done really, really well on that aspect of analyzing, interpreting data, what elements have not been assessed yet, which that white space is probably as important as all of the, beautiful colors. And then what elements need to be retaught because students struggle with them. And there is sufficient evidence to show that we need to go back and work on this more. So this is a screenshot of our school reports. We analyze, or we present this data for you for your analysis and interpretation. Let's go first to look at complexity. So we are going to look at what grade level band these questions fall into. Cool. How can we test natural selection? So this is one of the phenomena on our site where we look at stick insects, and students do kind of a Darwin's bird beak lab where they take toothpicks and they take different types of different colored backgrounds and different colored toothpicks, which are meant to represent the stick insects. And we have all this data that they're looking at. The data shows how, the change in numbers over time and how these toothpicks survive from generation to generation, and the change in population between all those things. The question, and there's a lot more context presented on the site, but I just want to give you a little speed read of it. So the question that we want to analyze is explain how the evidence in the two tables supports the following claim. In different environments, some traits are more advantageous, and this increases the probability of passing down of the advantageous trait. And now at the bottom of the screen, it's going to be a little colorful bar. It's going to pop up, and we're going to look at what grade level band this question is assessing. So is it K2? Are we looking at collecting, recording, and sharing observations? I don't know. The word probability in there kind of negates that possibility. Is it 3-5, where we're introducing quantitative approaches to collecting data, or multiple trials and qualitative observations? This is well beyond qualitative observations. So it's definitely more complex than that. Grade level 6-8, now we start to look at quantitative analysis. We're looking at causation versus correlation, basic statistical techniques of data and error analysis. All right, that sounds pretty reasonable. And then grade levels 9-12, now we're introducing more detailed statistical analysis, comparing data sets, like if there were 2 data sets and we were comparing them for consistency, and using models to generate and analyze data. All right, so let's give our analysis of this. This is a grade level 9-12, not only in content, but also in what we're doing. Students are looking at change over time. They're looking at multiple data sets, and there are actually several different graphs in this phenomena on our site that students are analyzing, and they're drawing conclusions from the data that's supported through multiple different trials and data sets collected by different groups with these different color backgrounds and different color toothpicks. So this is a grade levels 9-12, and now we're going to look at what detail or what elements are covered through this. So we're going to look at the same phenomena and the same question and look at all of the bullet points within the 9-12 grade band and try to decide what details have been covered within this. All right, so we got our little stick insects doing their thing on that hand right there, and all of our data and our question. Are students analyzing data using tools to make valid and reliable scientific claims? Are they applying concepts of statistics and probability to scientific engineering or engineering problems? Are they considering limitations of data analysis? Are they comparing and contrasting various types of data sets to examine consistency of measurements? That's really important here. And then also, are they evaluating the impact of new data? Lastly, are they analyzing data to optimize or have it better fit with the criteria for success? Okay, cool. So think about this for a second, and we're going to give our responses. So what we are doing here is we're analyzing data to make a reliable scientific claim. So literally, we're explaining if evidence supports the following claim. That's very explicitly called out in the question. And then we're also looking at statistics and probability. So because students are looking at these trials, multiple trials over time in different scenarios, and where these different colored toothpicks or stick insects are in different colors of environments or boxes. And that's what we're looking at, is we're trying to look at some data and find some patterns within these multiple different sets, and the probability that things will increase, that certain traits will be advantageous and will increase over time in certain environments or not. So just to go back over this one more time, the importance of knowing the complexity and rigor of your SEPs is that we're looking for assessing the correct level of rigor. So if you're at the 9-12 level, you need to make sure that your questions are super complex, and you probably need to scaffold up to that. You need to know what elements of the SEP are being assessed and which still need to be assessed or taught. So if it's complex, there are a lot of very, very specific things that students need to do as you're going through the NGSS. We need to be intentional then about our assessment to make sure that our instruction and our assessment mirror what we want students to be doing, and they cover the full breadth and depth of the standards. And then lastly, you can use these strategies on lower grade level bands to scaffold up. So that chutes and ladders activity that we did is fantastic, because as you're looking to get students up to this 9-12 level, where they're looking at multiple data sets, there are really explicit steps that they take, or ladders or chutes, I guess, depending on your perspective, in order to get up to that level of complexity at 9-12. Let's talk about some motion, some vacuum chambers, some graphs and stuff. So the question here is, how can graphs describe changes in energy and motion? And I want you to think about the grade level complexity of the SEP. I'm not going to read all of the text over here on the left-hand side. This is not super important. What we want students to do in this is we just want them to think about how kinetic energy is different when a bowling ball and a feather fall in the vacuum chamber. So we give students this canvas, a kinetic energy sort of little graph they can draw. We want them to draw 2 lines to show the difference in how kinetic energy of these 2 objects will change over time as they fall. Students have to draw one black line to show the change of the bowling ball's kinetic energy over time. and then draw a second red line to show how the feathers kinetic energy will change over time. This is one of the assessments on our site, and I want y'all to, as the colorful little bar appears on the bottom there. Thanks for good timing with the sound effect and stuff, Aaron, you're a pro. So I want you to use your stamps and make a stamp next to one of these grade levels for what grade level complexity you think this question falls under. And after an appropriate amount of teacher wait time, we are going to give you our analysis of this question, which is 6-8. Great job. So because what we're looking at really is correlation between mass and kinetic energy. So these two objects have different mass by a lot. And even though they move at the same speed in the vacuum chamber, their kinetic energy is, dramatically impacted by the difference in their mass. So what we're looking for students to do is just show just a difference in curve of the kinetic energy as it increases over time because the mass is so different. In grade levels 9-12, and we could use this for grade levels 9-12, where maybe we'll give students some more quantitative elements in this. And so maybe explain at these different, with these different variables, these different values, what we're looking for here. But because this is really just qualitative and we're really just looking to show the correlation between kinetic energy and mass with this question, this falls at the grade level band 6-8. Okay, cool. Awesome job. Thank you all very, very much. Now do it again. So we're going to look at the elements within grade level 6-8. And I want you to decide in these little boxes over here on the right, what elements you think are covered in this question. Again, students are drawing 2 lines to show the difference in kinetic energy over time for the bowling ball and the feathers. So they're constructing, analyzing, or interpreting to identify linear and nonlinear relationships. Are they identifying temporal and spatial relationships? Are they showing causation versus correlation? Are they analyzing interpreting data to provide evidence for phenomena? Are they applying statistics and probability? Are there limitations of data analysis that we talk about here? Are we looking at similarities and differences in findings? And are we analyzing to determine an optimal operational range or make sure that these meet the criteria for success? Thank you all very, very much for participating. This is fun, right? We get to really grapple with this stuff. All right, let's show our analysis of these questions. So y'all are on the right path, but I do want to explain why things are and are not tagged in this question. So students are definitely identifying relationships. They're having to construct graphs to show those relationships because we're looking at 2 different lines. We are trying to figure out whether there is a relationship between mass and kinetic energy. So they aren't showing temporal versus spatial relationships in this. We're really just looking at the comparison between kinetic energy and mass between these. However, I will say that you could definitely make the statement that they are comparing temporal relationships, showing the change in kinetic energy over time. That is literally one of the variables we're looking at here. So I'm going to say like maybe, but that's not explicitly what we're looking for in this. Students are distinguishing between causal and correlational relationships. It's qualitative. There isn't really data that we give them on what the kinetic energy is. We don't ask them to calculate that in this. So because this is qualitative and not quantitative, there really isn't much that we go over in this to describe how the kinetic energy is, it can be quantified. It's not really this. We definitely have questions within this cluster of questions. And this is just one question within a whole bunch around this phenomena where we ask students to distinguish between causal and correlational relationships in data. But they are absolutely analyzing and interpreting data to provide evidence for phenomena. At the very, very end, though, analyze and interpret data to determine similarities and differences. So though there are differences in the kinetic energy over time for each of these objects, we aren't looking at differences in findings. So if, and so this is another example where you could easily write a question that hits this, where if we had students do the same experiment, but not in a vacuum chamber and just dropping stuff off the second floor of your building, which hopefully you're not going to drop bowling balls off of there, but maybe you have a more liberal atmosphere than I've had at schools that I taught at. But if you want, you could give a scenario where students do this with with air and with friction, and allow them to grapple with the fact that the findings were super different when they did the experiment here versus when we're looking at this experiment in the vacuum chamber. But we're not looking at differences in findings here. There's one trial, there's just one situation with two different objects. So not really similarities and differences in findings for this one. But awesome job, y'all. Now, I want to try to put this together for you to make it really, really clear how you can scaffold up. The progressions are so beautiful. We're just total nerds with this, so we really, really like this. But what we're looking to do here is show you examples of how we can look at the same pieces of data and scaffold up from grade levels 3-5 to grade level 6-8 to grade levels 9-12. So at the 3rd, 5th level, and what we're looking at here in this data is global sea level fluctuations. So one is over 550 million years and one is over 25 years. So a significant difference in the scale of these two graphs, but they are looking at the same thing and also looking at it in different ways. So one uses some really, really complex measurements of ice cores and geological formations across the globe to get these two different curves, the Exxon and the Hallam et al. Curves. And we describe this in the phenomena. So the 3rd, 5th level, what we want students to do is look at similarities and differences. So we can ask, what are the similarities between how data was collected for these graphs? And then what are the biggest differences between how data was collected for these graphs? To bump it up another level, we can bring it to 6-8 and say, all right, so a classmate makes the claim that sea level changes have been caused by humans. Use the data below to evaluate their claim. So you can hit a couple elements in 6-8 where students are looking at causal versus correlational relationships in data. Really, really interesting things because this is 550 million years and y'all have not been around for 550 million years to be messing with the levels of the ocean. They just change also, and arguably, and I do agree that the data shows that we have had a significant impact on the climate and thus the sea levels over the course of the last 25 years and maybe 100 years, because we should be on this downward slope and we're not so much anymore. So we can use this exact same set of data and ask a question at the 6-8 level to hit a couple of those levels. And then let's scaffold it up one more time to the 9-12 level. What's the probability that sea levels will continue to rise at the same rate as the past 20 years? So now we want to talk about rate. So we want to talk about slope. What's really interesting about these two different graphs is that one shows things trending downwards, one shows them moving up. The scale and scope of these two images are very, very different, but we do want to allow students to kind of grapple with this and make sense of, or describe why they think something is true or not. And throwing in probability allows us to use a little bit of the statistics and mathematics in there. It's mostly going to be qualitative, but you could go deeper with this and give students a quantitative, the slope of this, calculate the slope of that, and explain the probability and all of that. So that is an example of how to scaffold all this stuff up. We do this on Inner Orbit. We work really, really hard to scaffold up these questions so that you don't have to, because it's hard to write all these questions and think about how the progressions change over time.
So to wrap it together, we're going to do one more activity where we're going to be analyzing assessment items for complexity and detail very quickly, just to pull it all together to practice it one more time on a new phenomenon. So for this activity, I'm going to give you a new phenomenon and some sample questions, and you're going to be figuring out what are these questions actually assessing. I'm going to do a silly kind of example of what this activity is because it's a little tricky. This is a tricky idea, and then we'll give you the actual science phenomenon and how you're going to analyze those questions. So here's my silly example. What I'm going to do is I'm just going to give you the complexity. Got a little bit of a gimme there, that we're going to do the third through fifth level of complexity. And what you're going to do is once I give you the phenomenon and the questions, you're going to identify 3 key words in the element list of the whole grade band level complexity that you feel like the question is assessing. So here's my example phenomenon, which is box office sales of superhero movies from 2014 and prior. And that's my data that I'm going to be analyzing, interpreting. And the question that I'm going to try to figure out what is it actually assessing is, what statements can you make about the popularity of superhero films from 2014 and prior? So what I'm gonna do is I'm gonna look through this list over here and see what keywords do I feel like this question is assessing. So I feel like students are being assessed on the use of pie charts. They're using that type of data to analyze, interpret. So that's gonna be one of my 3 keywords. I'm going to pull out the keyword interpret because they really are having to look at this visual with some data, some specific quantitative numbers to the side, and make a statement. And then lastly, I'm going to pull out mathematics, which does seem kind of like a gimme, like we're talking about data, there's going to be math. But at the 3rd and 5th level, actually knowing place value and understanding like the difference, relative size of numbers is important. So I'm going to pull out this mathematics idea as well. So those are my 3 keywords that I'm going to pull out from this list of elements that I feel like this question is assessing. So we're going to do that now, but on a real science phenomenon, not superheroes. So Brendan's going to introduce the phenomenon, and then I'll give you the sample question.
But if you want to talk about superheroes more, we'll hang out after this, and I could totally get down because those box office numbers do not reflect the current state of Marvel and all that. Anyways, so we're going to talk about for all of these examples that we're going to look at, or the one question we're going to look at after this, we're going to talk about this phenomenon. It's comparing the mass, the diameter, the density, and the gravity of all the planets, sorry, Pluto, in the solar system. And we're going to be looking at the DCI ESS1b, that's Earth in the solar system. We're gonna look at the cross-cutting concept, scale, proportion, and quantity. Duh, we're looking at this graph, look literally the scale of all of these elements in different planets. And finally, the actual questions that this phenomenon is used for on our site are at the middle school level, but you could easily use this at different levels.
Speaking of different levels, we're actually going to be asking a 3-5 level complexity with the 6-8 DCI. So this is kind of like a mix and matching or a way you can scaffold up. So again, what you're going to do is once I give you the sample questions, you're going to identify 3 keywords in the grade band 3-5 that you feel like this question is assessing SEP. And we're going to make another word cloud. So if you want to get your phones handy, it's going to be a new QR code, a new link in the chat. Thank you, Brendan. Feel free to scan that as well. So you'll be able to insert your 3 keywords. Okay, so without further ado, here is the question. What SEP elements is it assessing? What patterns do you see between mass and the force of gravity when looking at Mercury and Mars? So what are 3 keywords that jump out to you in the list of all of the elements that you feel like this question is assessing? So just a reminder that the larger the word, that means the more times it's been submitted by you all. Amazing. So patterns, that was a big part of looking for patterns in data. Relationships, comparing and contrast, beautiful. Relationships between the data, awesome. Analyze, awesome. Beautiful. So really what you guys did there is you analyzed these assessment items for what I kind of gave you the complexity already, but you analyzed for the level of detail of what are the actual skills this question is assessing and asking students to do, which is so important when writing curricula and then writing your assessments to know intentionally what you are assessing or maybe leaving out of your assessments as well. So to cognitively wrap up what we did today and Bo, I want us to just reflect on everything we've done in the past hour. We have talked about this idea that you can analyze your assessment items for 2 things: complexity using the grade level bands and for level of detail using the elements underneath. Knowing both not only equips you, as I just mentioned, to be intentional, but to also scaffold up your assessments to your current grade level band. So if you're in a higher grade band like 6-8 or 9-12, you can still focus on your 6-8 or 9-12 DCI or CCC, but then intentionally ask questions or have activities that are in the grade band prior to scaffold students up to their current expectations. You guys were amazing to analyze this, and we really hope to be able to support you with data to inform your practice as well. Just really quickly, we're offering free pilots. We've mentioned this before with our sites. You guys can do, any type of inventory you might need or just kind of play around with assessments. And then we also do sessions like this, but for schools and maybe a more 90 minutes too. So it's a little more collaborative, not as webinar format. So we'd love to talk to you about either of those options using our site or different school sessions we can provide for you.